Welcome to Brightly Innovation. I'm your host, Lidia Paulinska. Today we are showing highlights from Nvidia Graphics Technology Conference, also known as GTC 2017. The conference has been a technical conference that focuses on the software development for scientific visualization and gaming development. In recent years, the main focus application for game developer and gamers has shifted to being the lead event in deep learning and artificial intelligence, which is the basis of the new autonomous cars, drones, and image processing for the internet. Please enjoy the highlights from the several of the exhibitors showing their technology and key announcement from the keynote.
Ladies and gentlemen, please welcome founder and CEO Nvidia, Jensen Huang.
Welcome to GTC 2017. Before I start, I just got to say, all of everything you've seen so far and everything you're about to see were all created by NVIDIA's creative organization. There are two dynamics that are happening in our industry at the same time. I'm going to talk about both of them. This is the first one. For the last 30 years, we have benefited from one of the most powerful technological revolutions that anybody's ever seen. The combination of two effects created what is known as Moore's Law. One, architectural innovation that makes microprocessors better and better, more and more performant through architectural techniques. The goal is to find instruction-level parallelism. Now, the transistors that we added, more and more and more transistors, wouldn't have been possible to use if it wasn't because of a second law, the law of Dennard scaling. Dennard scaling basically says that we can put more and more transistors into a constant area and run them faster and faster, so long as we continue to reduce its voltage, so long as we continue to make the transistor smaller, reducing its capacitance. And by doing so, the combination of these two factors, more and more transistors, running them faster and faster at a lower and lower voltage, allowed us to continue to advance performance within some constant energy envelope. Some would call this the second era, not of processing, but the second era of computing altogether. As you know, when you guys are doing a search on Google, somehow it magically knows what kind of information you're interested in. When you're watching movies on Netflix, somehow it magically knows what are other movies that you would enjoy. And when you're shopping on Amazon, it's amazing that every single page is personalized for you. And that it knows, based on the type of shopping habits that you have, there are other things that you might be interested in. None of those programs were written as a sequence of instructions specifically by engineers. All of that was made possible by machine learning. It's learning from all of your behavior and all your interactions with that service, and over time, it becomes more and more predictive. Ladies and gentlemen, I would like to introduce you now to the next chapter of computing, the next level of computing. I would like to introduce you to something that has taken several thousand engineers, several years to create. It is a masterpiece on many levels. It is the most complex project that has ever been undertaken. Arguably the most expensive computer project the world's ever done. Ladies and gentlemen, the Tesla Volta V100. This is made out of TSMC's 12 nanometer FinFET, and I'm just getting a little exercise up here. 12 nanometer FinFET. The part that is really shocking is This is reticle limits. Reticle limits basically means that it is at the limits of photolithography, meaning you can't make a chip any bigger than this because the transistors would fall on the ground. Every single transistor that is possible to make by today's physics was crammed into this processor. 21 billion processors, almost 100 billion vias, little connectors, 100 billion vias. That's it. That was what we talked about today. We talked about two things. We talked about the fact that accelerated computing is really coming to the fore. This is the rise of accelerated computing. Our GPU computing platform has been adopted by high-performance computing scientists all over the world. And recently, with the advent of deep learning and the breakthroughs there, we're now seeing a new era in computing we call the era of AI. Volta is the next generation, next giant leap into that new world. We also announced that we would like to expand the reach of deep learning to proliferate this capability, to democratize the ability for every single IoT device around the planet, the trillions of them that are going to be able to use deep learning in the future, to be able to access a world-class design. We're going to open source the Xavier DLA design.
My impressions of what I've seen so far at the GPU Technology Conference this year. From what I've seen, there's been a little bit less every year that directly affects the gaming audience, but in a larger way affects a much larger community of folks who use things like deep learning, artificial intelligence. It's no longer about the cards you just plug into a desktop or a notebook PC. It's no longer about the chipsets we use just for that anymore. But now we're seeing folks that are plugging, that we've seen in the game industry, like Unreal. The Unreal Engine is here. But it's not just about games anymore. The demos just show just a fraction of what they're known for now. It's like it opens a door saying, oh yeah, we've used this footage in a game, but imagine what we can do now in the cloud. Imagine what we can do now for education, for businesses, for academia. So looking at this show now, and if you look at the agenda, it's not just about gaming. Gaming is what brings me here, and there's definitely some great folks on the floor. And the gaming media reflects it. We're still here. We cover it because we know Nvidia is part of our community. It affects the kind of games we see. It affects the specs that we'll see with the kind of games that are out there. I tried Batman VR. Fantastic demo. Just tried it. Still a little sweaty from it. It definitely gets you going, gets the adrenaline going. So there's some great examples of consumer-ready VR applications that use the PhysX engine. So wonderful content, and Robo Recall, also by Epic as it happens. Also out in the VR Village, which has been running every day during this show. Wonderful material. And this is the stuff that consumers touch, that we look at, all of us, the gamers and people who are just curious about VR. And it's, again, part of the ecosystem. But when you see everything all the news that's coming out of here, this is stuff that's mind-blowing, mind-bending stuff that's going to be affecting our world at large. It's bigger than gaming, but you can be sure that it's going to find its way back down into our ecosystem. So keep an eye out on the news that's coming out of our site and many other sites out there for following the GTC 2017 information. Follow that. You'll see what I'm talking about. It's bigger than just the gaming audience, but if you love gaming, we have some great news that's coming out from here too. So thank you very much.
So what we're showing here is we're showing a rack-level demonstration of composable infrastructure. If you are not familiar with composable infrastructure, you're going to start hearing a lot about it as we move into the future. So what we're showing here in this live demonstration is the ability to compose machines based on pools of aggregated resources. And what I mean is, here we have a box full, or a pool of CPU resources. Inside of these CPU resources, there's no storage, there's no networking, there's no GPU devices. On top of that, we have a box full of GPUs. On top of that, we have a box full of storage devices. On top of that, we have a box full of disaggregated networking cards, individual networking cards plugged into a 2U24 bay chassis. All of that is connected to our intelligent fabric switch. This is the Liqid PCIe fabric switch that has the Liqid software living inside of the switch. And what the software does, it enables composability. And what composability means is grab this CPU, grab those 4 SSDs, grab these 2 networking cards, grab that GPU, and create me a physical bare metal server. Just like plugging stuff into the socket of the motherboard, except that bare metal server is dynamic. When you want to add more resources to that bare metal server, you don't have to send a guy with a cart to plug in more storage devices. All you do is reprogram the fabric and suck in more resources from those pools of connected resources. Everything in our world eventually is going to be a policy-driven environment. The admin will set policies that say, hey, when the storage utilization of this server goes above 80% utilized, automatically reprogram the fabric and suck in more storage resources. At 10 o'clock at night, when this server is no longer going to be using this expensive GPU resource, reprogram the fabric, put that GPU resource back into the pool of GPU resources, and allow someone else to use that resource for another task or another application. We allow the sharing and the dynamic configuration of all of these bare metal physical resources. What Liqid does is we build the technology that enables composability. We enable the PCIe fabric switch that interconnects pools of these resources, and more importantly, we build the software, the orchestration software that allows you to orchestrate and build servers, physical bare metal servers, based upon those pools of disaggregated resources. Does this platform work well with multi-tenant or virtualized environments? And the answer is absolutely. The beauty of our application and our software is all of our software lives on our fabric switch. What we deliver to you is a bare metal node. So onto that bare metal node, you can load whatever software you want on top of it. If you want to run a Linux OS, you can run a Linux OS. If you want to run VMware or another virtualization layer, we absolutely support that. What we will enable is we'll give the application the opportunity to have access to an API, so the application can come in and start reprogramming the fabric and making some of these intelligent decisions at the application layer. Our belief is if you deploy VMware on top of a dynamic, flexible infrastructure, you're going to make a virtualized environment that much better.
So welcome, very excited to see that you're here at the Hewlett-Packard Enterprise booth at the Nvidia GTC conference. We're really excited to unveil quite a few of our innovations today. We've got innovations from a systems design and compute to optimize for GPU computing. So really in our booth today, what we have is Hewlett-Packard Enterprise has had traditionally a very strong portfolio of capabilities, compute capabilities for deep learning, GPU computing, and artificial intelligence. And really what we have is a flagship HPE Apollo product line. The Apollo 6500, you see right behind me on the screen here, has been our flagship product. It maximizes GPU capacity with 8 GPUs per node, and it's ideal for deep learning environments, specifically for handling massive amounts of data and doing those training, the training modules for deep learning is what it's ideally suited for. We also have the HPE Apollo 2000, which is our what we call as our bridge to scale-out architecture in the enterprise, and that's ideal for inference engines for deep learning. We also have a new announcement to make about the HPE SGI 8600. This is a platform purpose-built for very large, petaflop scale deep learning applications with liquid cooling capability. So this really provides thousands of nodes, right, to provide massive deep learning kind of workloads. And today we are finding a lot of customers are using these kinds of large clusters for both high performance computing as well as deep learning applications. And we've done a lot of work to optimize the design for performance, both from GPU compute to GPU CPU compute capabilities, for efficiency, power efficiency, as well as for scale, to go all the way up to thousands of nodes. Now, we're very excited to let people know that we are supporting the latest generation of Nvidia, Tesla P100 GPUs, and those are pretty standard in some of these platforms that we are bringing out from our portfolio. Now, in addition to actually having these infrastructure capabilities and hardware, we are also showcasing some brand new solutions, which is right next to me here in the booth. We have a number of solutions for the financial services industry, which has rapidly becoming a big consumer of GPU-based computing applications. For example, we have the HPE Trade and Match server, for high-frequency trading applications for investment banking and trading environments. We have the risk-compliant archive, and then we also have our trader workstation where we've optimized the trading environment for traders. So we have an end-to-end solution from a compute perspective for high-frequency trading for investment banking environments. Now, in addition to that, we're very excited to talk about our sort of new solution on deep learning. We've been partnering with Kinetica, a leading analytics software company that leverages GPU-based database architectures and other deep learning frameworks to actually build a fraud detection solution. So we've actually announced that we have the ability to help commercial credit card transaction processing to use anomaly detection techniques to actually identify and prevent fraudulent activities that are happening with credit card transactions. We also have a risk mitigation for trading as well, solution that we put together. These are typically fairly integrated package solutions that make it simple for customers to essentially plan, deploy, and get the infrastructure up and running to drive the applications. Now, in addition to all of these, we also have what we call as our visualization solutions for remote visualization and rendering and other capabilities. So we're actually showcasing what we've done with our basically our grid capabilities from Nvidia for leveraging our entire remote visualization and virtual desktop infrastructure and visualization applications as well. So we have that entire portfolio also featured here.
Hello everyone, I'd like to introduce the Inspur JBOG, 16 GPU JBOG for artificial intelligence applications that we have been cooperating for many years with Baidu for the driverless car technologies and a lot of the artificial intelligence projects that they've been working on. The uniqueness of this system is it is very dense. It has 16 GPU cards in one server. So you can daisy chain up to 4 of these boxes to have 64 GPUs in one cluster. This is the most powerful AI hardware platform today. It's the Inspur AGX2, our most advanced application server for AI. So we are going to be introducing this new platform into the market together with Nvidia later this afternoon. This server is 2U, very high density, and it has 8 GPUs in 2U. And the flexible and modular design, you can have either SXM2 or with SXM2 with NVLink 2.0 enabled, or you can swap out this card, this board here, and replace it with a PCIe board for regular PCIe card, a Tesla P100 series. Also, the board here is modular as well. Currently we have the Intel Pearly board to debut, and then we can also replace it with the Open Power board, the Power 9. We're working on that as well.
Hi, I want to talk a little bit about Power AI, IBM's enterprise software distribution for deep learning and machine learning. So we're really trying to make deep learning far more accessible to developers and end users around the world. And we're really doing that by rolling together a software distribution of the most common open source deep learning frameworks: Caffe, Torch, Theano, TensorFlow, and Chainer, as well as Nvidia Digits, and all of their dependencies in a way that's really fast and easy to deploy. And that brings huge value to people who are trying to get started with deep learning or trying to deploy deep learning at scale. So we can reduce that time to deployment and get them running their real work and developing and training on models faster. That means that they can have frameworks that are tuned and run at their peak performance out of the box. And then we're doing tuning for our Power8 with NVLink systems, our servers in IBM Power Systems, such that they could get performance that they don't get on other architectures. And then finally, we're delivering validation and support for these deep learning frameworks in Power AI. What that means is that we go out and test the pre-rolled binary software distribution before it ships out to the end customer, and then we allow those updates to be distributed through that repository and for them to be tested and be known good and working right when that end customer issues that update command. So we're making deep learning faster to deploy, more accessible, and more performant, and that really means that people can start and deliver their value in their applications far more rapidly. So this is our IBM Power Systems SA22LC for high performance computing server. It's the first server with Power8 with NVLink technology, where we embed the NVLink interface, a far broader interface, into the Power8 system chip and use that to connect to Nvidia Tesla GPUs, the Nvidia Tesla P100s. This is really a game changer for those who've been working in the high-performance computing space, who are working in deep learning. We're trying to develop new kinds of applications for servers and deployment in all kinds of domains, because it helps eliminate that PCI Express bottleneck.
I primarily am here showing our Server Challenge virtual reality game. It's basically a game where you're going to be able to walk into an IBM Cloud data center, and you can actually assemble a rack. And what you're doing is you're plugging in hardware, you're sliding in drive bays and network cables and everything that goes along with hardcore cloud computing, because bare metal is really the advantage that we have. And we're also talking about our Nvidia P100 cards that we have.
Hi everyone, welcome to GTC 2017, which is really a hotbed for GPU innovation. We're showing a variety of really exciting solutions today. Everything from computer-aided engineering to the latest in rendering for media and entertainment or product design. Given the interest of this audience, I'm going to focus on rendering. One of the announcements we made was something we call the VCA Certified Rendering System Program. This allows system partners of PNYs to take 8 of our most powerful GPUs, in this case a board known as the Quadro P6000, and combine the power of all 8 into an interactive renderer that can be used for media and entertainment or product design applications. Behind me, I've actually got an example of one of these systems. This chassis contains 8 P6000 boards, and it's running the software package that we call the VCA Certified Rendering Software Stack, and provides the ability to run Nvidia iRay or other renders such as SolidWorks Visualize Professional, but with photorealistic output. The advantage of this solution as well is it can be shared. It's accessible over a network. It supports 2 different types of rendering. One is batch rendering, where you submit a job, it goes into a queue, and when the job is done, that is returned to you. The beauty of this is it can be shown on a desktop PC, a notebook PC, or for that matter, a tablet or a smartphone. So you can have photorealistic graphics generated from design files or CAD files using the VCA. The other mode it operates in is what we call streaming mode. The advantage of streaming mode is it's interactive. Here I've got an Audi supercar. If I want to see it at a slightly different angle, I just move it, and you'll see immediately that it's rendered. And this is actually ray trace rendering using SolidWorks Visualize Professional based on Nvidia iRay technology. So it's actually modeling the physical behavior of light. If I needed to work with a material, like for example a different color, simply drag it and drop it, and you'll see it's re-rendered. So the degree of interactivity that we provide here has never before been available.
This VMware booth, we have a virtual racing car and show us how it feels to drive a virtual desktop running Nvidia Grid graphics. So how does it feel? It's a simulator, so it's meant to be a simulator than a game. Yeah, so we've got about 180, 190 frames per second to our virtual desktop. You're not actually seeing that many frames per second, but that's what's going to the desktop. And it feels pretty realistic. If it's not realistic, people won't be able to drive the car. Okay, so I guess it deserves an explanation what we set up and why. This is a kind of a thought about end-user computing. End-user computing is not easy to show off when you're just talking about bringing up an application a little bit faster. So I thought it might be better if people could feel and experience that with their hands and feet. But this is all hooked up to this little client right here. This Zero client is exactly how it says. It's a Zero client. Doesn't have a real CPU, doesn't have much memory. It's just sending the frames to the screen so that you can see what's going on. The real action happens on the back end. It's a virtual desktop that VMware leverages ESX host hypervisor on a server, and we present that virtual desktop, which is Windows 10, through the Nvidia graphics that we have in that server. So it's an Nvidia M60 that allows us to achieve those frame rates that you just saw earlier.
I am showing the Cerner SkyView echocardiogram workflow powered by Horizon View and Nvidia Grid. What we have is a Zero client that is rendering this view of an echocardiogram workflow. And the benefit of this to an organization would be using a low-powered client like this. You can provide secure access to an electronic medical record, providing the clinician an experience where you're not exposing protected health information, you're keeping the data secure inside the data center, and you're giving them a level of performance and flexibility in how they do their job. So we've got this system currently logged in to a Horizon View session that's showing the echocardiogram. And if we'd like, we can actually move that session over to a different type of endpoint, in this case, an iPad. With that, you're able to actually secure, like I said, that clinical experience, provide the clinicians the flexibility to do their job wherever they see fit. And then when they arrive in a patient room, they can take their employee ID, tap their badge on this endpoint, turn to the patient, start treating them and saying, how are you doing? We've changed your medication in the last 30 minutes. And by the time they turn back around, the medical record's right back where they left it.
One of the most impactful problems of our time is going to be how we manage our urban environments and cities. There's a number of problems within cities that we're facing, from operational efficiency, parking and traffic congestion, as well as public safety, just keeping people safe and really understanding situational awareness and what's going on in cities. One of the most important sensors that we have in cities are cameras. It's a really rich sensor. And in the next 4 years, there's going to be about 1 billion cameras streaming live, 24/7 video, all around our urban centers. And it turns out that this data is extremely rich. There's many questions we can answer with the data that's hidden inside of all of these video streams. And you can imagine 1 billion cameras worldwide, that's a lot of data. AI and GPUs are really going to be the foundational technology to be able to transform those pixels from video into actionable data. And so what we're doing at Nvidia is announcing a platform called Metropolis that allows us to take all of that video and extract really rich, meaningful metadata from it.